In this video, we will practice using the law of sines to solve triangles when you are given the ambiguous case. Ambiguous means there's more than one possibility and we're not immediately sure how it's going to turn out, which situation we are actually dealing with. Now, we use the law of sines anytime we are given angle, angle, side, meaning two angles and the non-included side, or if we're given angle, side, angle, two angles and the side in the middle, the included side, we will definitely use the law of sines whenever we're given these two situations. And these are not ambiguous. This just will give you one triangle and you solve it and it's fine. There's one solution. You don't have to worry about it. But every now and then you will get this third situation, side, side, angle. Two sides and an angle. This is the ambiguous case. When you see this set of information, you can't be sure. Will you have one triangle? Will you have two triangles? Or sometimes this will form no triangles at all. So we're going to play around with these numbers and figure out what's happening. Okay, so let's draw ourselves a picture. Now, as soon as you see that you are given an angle, a side, and a side, right away you know that you're dealing with the side-side angle situation. You know that this is the ambiguous case. So here's what I recommend. As soon as you realize that you're dealing with the ambiguous case, I want you to shoot for this. You're going to draw your diagram starting with putting a horizontal line down. Okay, then you're going to go ahead and form yourself an angle. Alright, now this angle is going to be the angle that you're given. So here we're given this one angle, and so I'm going to go ahead and call this A. Now, this so we're given these two sides. Now, side A has to be across from angle A. So I'm going to look at this like it's a hinge. So I am going to temporarily, I'm going to put this as a dotted line because we don't know if it's going to be like this, or if it's going to be like this, or if it's going to be like this. We don't know. That's why this is the ambiguous case, because there's more than one possibility. So because we don't know, that's why I'm going to put side A as a dotted line, because we don't know. Okay, so but this is going to be the 25. And so that means side C, the 26. Put the 26 here. Notice that I did not make this a dotted line. This is solid. This is fixed. So this side of 26 and this angle are not moving. These are rigid. They are frozen. So if this is side C, that means this would be angle C. That means this must be angle B up here. Okay? Now, to figure out whether or not we can make a triangle and whether or not there can be two triangles, we need to figure out the height of this triangle. So this would be the height. If we put a vertical line right here, this would be the height. So I'm just going to call this H right now. And let's do this calculation off to the side. So the sine of 70 degrees would equal opposite over hypotenuse. So that would be H over 26. So that means if I multiplied both sides by 26, I guess I'll go ahead and show it. If I multiplied both sides by 26, alright, to where these would cancel out, then that's going to leave me with the height, 26 sine 70. So I could just put that in my calculator real quick, 26 sine 70. Okay, carry 3 decimal places. So I've got 24 24.432. Okay. So this is approximately 24.4. Now, we can start to analyze and see. First of all, can we make a triangle at all? Now, the time when we can't make a triangle is when this side is too short. All right, when this temporary side, when the unknown side, the side that we think of it as being on a hinge, if it's too short to reach the ground, you can't make a triangle. So, is this long enough to reach the ground? Well, yes. The height is 24.4, and side A is 25. That's longer. So it will reach the ground. So we can make at least one triangle. So the question is, can we make two triangles out of it? And so here's the thing. This 25 is long enough to reach over here. So the question is, would it also fit inside the triangle like this? And the answer is yes. Because looking at AB, looking at side C, the 26, this is longer than the 25. So if the 25 were here, it would fit. So the 25 could fit here where the green is, or it could fit out here where the blue is. So there really are two different triangles that we could make. So that means we're going to have two different solutions to this problem. Okay, so we will have one solution that looks like this. Okay, but we will have another solution that looks like this. Okay, so this is our A and our B and our 26. But like I said, it could come in like this and make, so this could be angle C. So this is what the other solution would look like if the 25 was in like this. Okay, so let's solve them both. Alright, let's start with the acute triangle. We are missing two angles and a side. So we are missing the measure of angle B. So we're going to have to find that. We're missing the measure of angle C. So we're going to have to find that. And we are missing the length of side B. So we will have to find that as well. So let's use the law of sines to find this. Okay, well, what do we have? What do we have? I see the 70. That's really big. Hold on. I see the 70 and I see the 25. Alright, we have an angle and the opposite side. So we will set up our law of sines like you do. We will say the sine of 70 over 25 is equal to other stuff. So I see the 26 that we haven't used yet. So my eyes are drifting over to that 26. Alright, that 26 is across from angle C. So that's what we're going to go to next. So that means this should equal the sine of angle C over 26. So I should be able to solve this for angle C. So if I multiply both sides by 26, that's going to get it done. Multiply by 26. So that way these 26's are going to cancel each other out. and we will have sine C by itself. Okay, so the sine of C is going to equal all of this stuff. So I've got 26 sine 70 over 25. But of course I want the measure of angle C itself. And so what you have to realize is if you have the sine of an angle but you want the angle itself, then you need to do the inverse sine. So the inverse sine will give you the angle. So that's what I'm going to do. So if I do the inverse sine of all of this, alright, 26 sine 70 over 25, that's going to give me the measure of angle C. So I'm just going to put that in my calculator. Alright, so I need inverse sine. So I'm going to hit second sine. And then I need a fraction in here, so I'm going to go ahead and hit alpha y equals. And now I need 26 sine 70. So 26 sine 70 over 25. Alright, inverse sine of all this, and boom. I'm getting 77.763 degrees. Okay, I didn't leave myself a lot of space. Alright, so I have just found the measure of angle C. So I could put that right here, 77.763 degrees. Now I could easily find the measure of angle B because these angles have to add up to 180. So I'm going to just subtract these two from 180. Okay, so if I go 180 minus 70 minus 77.763, then I get 32.237. degrees. Okay, that just leaves side B that we need to find. And of course this is side B over here. So we can find side B using the law of sines one more time, because, you know what, I feel like I should change colors. No, pink won't work. Okay, so I've got side B and angle B. So I'm going to use the law of sines on those. So that would look like this. I'm trying to leave space for the other triangle, but I'm running out of space. Well, that's a lot of room over there. Feel like I should spread out a little bit. Okay, so I'm going to do this now. So I'm going to, I'll use the same ratio that I used before. So that's sine 70 over 25 equals. But this time I'll do the sine of 32.237 over B. Okay, so if I were to cross multiply on this, that would give me B sine 70 is equal to 25 sine 32.237. And then if I were to divide both sides by sine 70, Okay, so the sine 70 goes away. That's going to give me b is equal to whatever I get right here. So I would just put all of that into my calculator if I were you. You know what, I'm just going to show it this. I'm not going to show this every time, but I'll show it once right now. Alpha y equals, enter 25 sine stuff, so 25 sine 32.237. Notice how I'm using 3 decimal places. You should do the same. Over sine 70. Okay, so I'm getting 14.191. Okay, and so this is one solution that we're going to get. But this was the ambiguous case. Alright, this is the solution where we wind up with an acute triangle. Now, what about the solution when we wind up with an obtuse triangle, like this? Now, I had to use some of this space up, so I need to, maybe I'll just draw a line separating this out. Okay, now let's deal with this. I'm going to change colors. I'll use green for these calculations. Now, here's the key to the whole project. We cannot use the law of sines to find this obtuse angle. We can't do it like we did before, because when you do the inverse sine, it's always going to give you the acute angle. It will not give you the obtuse angle. In fact, remember, inverse sine has restrictions. It can only be between negative pi over 2 and positive pi over 2. That's negative 90 degrees and positive 90 degrees. Now we're talking about triangles. Triangles can't have negative angles. So we're really talking about between 0 and 90. Alright, that's the only kind of angle that you can have for inverse sine. So it's only going to give you an acute angle, something less than 90 degrees. So if you want to calculate and find this obtuse angle, you're going to need a different strategy. Here's the strategy that we're going to need. We're going to have to use isosceles triangle magic. So look at the old triangle that we did, the triangle where the side came out like this. Now I'm going to temporarily draw that triangle again in green. So there it was. Now we figured out that this angle right here was 77.763 degrees. That's 7. So what you need to realize is these angles are the same. Okay, I feel like I need to erase this real quick for a second. So you can really see the isosceles nature of this. These two angles are going to be the same. Because this side that's 25, we're looking at this as a hinge, sort of swinging back and forth. So we got the 25, if we swing it to the left, is the same 25 that we had when we swung it to the right. So these two images are the same length, 25 and 25. So that means these two angles are the same. Both of these two base angles are 77.763. Whoa. Okay, so the question is, how can I use that information to find this obtuse angle? Well, that's easy. Together we have a straight angle happening right here. Can you see it? Right down here, if you have a straight angle, okay, understand that this is going to be 180 degrees. Alright, and that's what's happening here. We have a straight line. So if you take a straight angle and you split it like this, these two angles are going to be supplementary. They're going to add up to 180. So if one of those angles is 77.763, how could you find the other angle? Well, you subtract from 180. That'll give you the other angle. Okay, so if I do 180 minus 77 point whatever it was, 763. Okay, that gives me 102.237. Alright, 102.237. That's the obtuse angle. So that's what we just found. Alright, so this obtuse angle in here is 102.237. That's how you have to find it. Okay, now I'm actually going to go back and erase this because it's just in my way. Oh man, I went too far. Okay, can I draw this back again? Okay, now that we got that straight, alright, we found the measure of angle C. Now we can find the other things pretty easily. Okay, in fact, let's get our little list going. We needed to find the measure of angle B, the measure of angle C, and side B. So let's make that same list. We need to find the measure of angle B, the measure of angle C, and side B. Well, guess what? We already found one of those. Alright, we found that the measure of angle C was 102.237 degrees. Okay, now we could find the measure of angle B now very easily because we have two angles inside the triangle. They have to add up to 180. So we could subtract both of these from 180 and that will give us angle B. Okay, so, well, it looks like I've already subtracted, well, that was 77, never mind. So I can do 180 minus 70 minus 102.237. That leaves 7.763. Okay, so that is angle B. Very small angle, 7.763 degrees. So the only thing we're missing now is side B. And side B is this down here. So guess what? We can now use the law of sines to find this, no problem. I'm going to actually use the same ratio I used before. The ratio that says the sine of 70 over 25 is going to equal. Okay, and now I'm going to use angle B and side B. So this would be the sine of 7.763 degrees over side B. If I cross multiply here, I get B sine 70 is equal to 25 sine 7.763. And if I divide both sides by sine 70, okay, that's going to give me side B. So just put all this in your calculator. I'm going to do that off camera. So this came out to be 3.594. Okay, so this is the other solution. Okay, so notice from the exact same information, I had two completely different solutions. All right, one from the acute triangle and one from the obtuse triangle. And that is how the ambiguous case works.